Okay, great. So Walt is going to be leading our Learn to Code session today. We're excited to partner with Venture Cafe Philadelphia. So I am Katie Zyko. I am the Pathway Program Director for Tech Elevator here in our Philadelphia campus. So I'm just going to go through a few slides just so that you understand kind of where we're coming from and who Walt is teaching typically. And if this is something that you may be interested in, we'd love to offer some information, or if this is also something you'd just like to learn more about, Walt's going to take you through a Learn to Code session. So if you want to go to the next slide. So Tech Elevator's mission is to elevate people, companies, and communities. We really believe in helping bright and smart individuals learn the skills to become software developers. And obviously software and technology are really keeping all of us connected at this point, especially during this time. So I think even more now, companies are realizing that they need to hire more software people. They need to hire people who are technologists. And we want to help our students, our hiring partners in the communities that we're in with that goal and help them elevate either their lives, their community, the company that they work for. We want to help them elevate that. If you go to the next slide, you'll see all 6 of our campuses. So we actually have 6 brick and mortar campuses based out of Cleveland. We opened in 2015 there, Columbus, Cincinnati, Pittsburgh, Detroit, and then Philadelphia just launched here this year. We're actually 30 South 17th Street, right in the Dwayne Morris Plaza between Chestnut and Market. Right now, unfortunately, due to the state of everything, we are delivering our classes remotely. But typically our program is 100% in person. We also just launched our campus here, a live remote campus where we're offering our program, our boot camp, to people in the country who may not live physically in one of the cities that we're actually in. And then the last slide here before I turn it over to Walt is just really what we offer. So our program is demand driven. We want people to be able to learn skills that are in demand. And it's practitioner led by our amazing instructors who really are not just instructors, but they're mentors. And they really do help our students make that career change going from one career to the next. So here are kind of the nuts and bolts. We are full-time, in-person, 14 weeks is our program. We offer three sessions a year, our fall, spring, and summer cohort. Throughout the program, you get 700 to 800 hours of development time where you're actually creating something. And then we're offering 2 languages, Java and .NET are the 2 that we offer. We believe in offering those because they're in the most in demand in the markets that we're in. And then when you graduate, you're considered a full stack code-ready developer. And last but not least, we do, obviously our students come through our program to learn those skills, but they also come through the program because they want to invest in themselves and find a job. So we have a program called Pathway, which really does hone in on their behavioral skills and hopes to eventually help them land that career and make that career change. So if there are any questions, I will put my email in the chat. At this point, I am going to actually hand it over to Walt, who's going to lead you through the Learn to Code session.
All right. Hey, guys. Happy to be here. My name is Walt Impellicceiri. I know it's a super long last name. You won't have to say it. It's okay. I just want to give a little bit of an intro about me. I'm actually an instructor at our Pittsburgh campus, so I'm not in Philly. I am over in Pittsburgh. I graduated from the University of Pittsburgh with a degree in computer engineering. So more of a traditional background, but I am just one of our instructors, and some of our instructors came from a traditional background. Some have been self-taught. There's sort of all over the spectrum. I have a variety of industry experience. I've been in the industry for about 13 years or so, which is actually probably one of the fewer resumes than some of our instructors. A lot of our instructors have a lot more years of experience than that, but I promise I won't short you today with knowledge. Some of the fields that I've been in, simulation, automation, healthcare IT for a significant portion of time. And then most recently, I was at a company that you may have heard of. It's a company called ModCloth, which does women's fashion, e-commerce retail. And they were, purchased by Walmart at the time. So I was also an employee of Walmart. I'm sure you've heard of them. In my spare time, I like to ride bicycles. I like to race bicycles. So I figured I'd throw that in there in case any of you are into bikes. I love talking about bikes as well. But let's get to it. Let's talk about, what we're going to talk about today. And so today is really an introduction to programming, to software development. It's really just going to touch on one particular feature within programming, but one that is incredibly important, and that's called Boolean logic. I want to sort of digest that right to left, so logic, and then maybe we'll get to Boolean. So logic, you know, you can think about it as it's decision making. It's sort of answering questions, right? It's like, do I want to do this or do I want to do that? So logic is littered throughout any software program that you write. Otherwise, it's not much of a program. It's just kind of going to do what it does every single time, which is valid, but oftentimes there's branch flow. You know, I'm going to go do this if this case is true, or I'm going to go do this if that case is true. So logic is a really important piece to software development. The term Boolean may be new to you, whereas logic is probably not very new to you, right? Boolean comes from, it's actually from a man named George Boole. He was an Englishman from the 1800s, I believe, but he sort of invented Boolean logic. And so this is kind of his namesake. He sort of came up with the formal language of the logistics that we're going to get into today. So just so you know where that term comes from, it is a bit of a strange term, but effectively Boolean is actually one of the simplest things in computer programming. Boolean is really just a type of data, and a type of data that can either be true or false. And so it's honestly the simplest form of data in all of computer science. Data is very prevalent in software, right? We have numbers, we have you know, lists of things, we have we have like, you know, integer values, whole numbers, we have floating point numbers that have decimals and things like that. We have characters, we have strings of characters. So those are all a little bit more complicated than just a true or a false value. That can just be one of two things. So while Boolean is one of the fundamental things, it's also one of the most important. And that's, again, because it allows us to make decisions. And so that's why I'm focusing the talk on this today. And let's just dive right in and put some concrete examples around this. I do want to preface this. If you have any questions, feel free to throw them in the chat. I may not get to them right away, but I would love to have plenty of questions to get to later on. I want to make this as interactive as possible. As the slides go onward, we're going to have some exercises that you guys can join in on. So I want to start with a little bit of, you know, learning, and then we'll get into more application of that learning. With that said, we'll start off with Boolean logic. You know, a little bit of an introduction. We write code in programs that map inputs to come up with an answer or to determine what comes next. So inputs you can think of as just like, you know, whether or not, let's talk about the simplest term. A light switch is, or a light is on or off. And our input to that light is a light switch, right? Is it up or is it down? And so the input, you know, if it's already up, if I turn it down, now I turn it off. If I turn it up, I turn it on. That's sort of the simplest form that you can think of as like an input. Inputs could be any number of things. One of the things that we often encounter today is we go onto our browser and we might read the news. And a lot of sites nowadays have what we call a paywall. You know, like you can view some of their articles, but you can't view more than X number of articles, or you can only view a portion of an article. And eventually there's, you know, some sort of subscription that you must have. Another thing that we have all the time are login pages, right? Like we have to enter our username and our password to get through a filtering process to make sure that we can log in to see whatever data we're getting to. Maybe it's our email, for example. Behind that, there's logic. There's the logic of, you know, if this is true, then do this. If that's true, then do this. And so let's start with the logical side of a login page. You have a username and you have a password. And we need to make sure that the username that you supply, along with the password that you supply, matches what we have on file. So let's say you're logging into your Gmail account. and you put in your username and your password, Google is going to take that data and confirm that that matches what they have on hand. And if it does, then the logic resolves to a true value. And therefore you're let into your email and you can do things. If it does not, it resolves to a false value, and then they'll do something else because of that. You know, they'll tell you that the data was incorrect, please try again, or they'll tell you your account is locked out, something along those lines. And so they're reacting to whether that logic resolved to true or false. Again, if it resolves to true, they're going to let you through. If it resolves to false, they're not going to let you through. And that's at the simplest terms. To build upon that, there are two bits of input there. There's not just one, there's two. And so we have to look at how those play together. And the way that Boolean logic plays together is with three keywords: and, or not. And so in this case, it's an and condition. We give it a username and we give it a password, and both have to match. So username has to match and the password has to match. If we were talking about an or condition, then it would just be maybe one or the other. But in this case, that doesn't make any sense. They both have to match. And so we check that the username matches and the password matches. Those are two discrete Boolean logic expressions that resolve to true or false. In the second example that I want to talk about, it's more of like a paywall example or a subscription pop-up. If they are brand new to our website, or if they have somehow exceeded the free limit of our website. So let's define the free limit as they get 3 free article views on our website, three news articles before suddenly they get this pop-up that they need to subscribe. And so if either they are, I can tweak this a little bit. So let's say I want to define what a guest is as well. So let's define a guest as someone who has, who has visited the website for the first time. And then let's say someone who's exceeded the free limit is again, they've seen a couple of articles. And so we want to display a subscription pop-up in either case. So we want to try and get someone to subscribe right away if we can. Otherwise, we'll let them cancel out that pop-up for a little bit and let them view a few articles, and then we'll show it again. And we'll continue to show it from there on out, right? So that's a case of either or being true. If I first visit the website, you haven't seen me before, then I'm a guest, I'm brand new. And you're gonna show me the subscription pop-up. Or if I've been to the website before and I've exceeded 3 views, then you're gonna show me the pop-up. If I'm in between, I've only seen 2, then I'm not going to see the pop-up because I don't match either one of those conditions. Not, we'll get to in a second, but it's really just to take something and flip it. And so not is almost like that light switch example, right? You either turn it on or turn it off. And so you're just nodding it with what it was previously. If it's on, I want it to be not on. If it's off, I want it to be not off, which otherwise is on. So not is almost the simplest of all of the 3. Hopefully that intro helps a little bit. I'm gonna get even more formal with it. So hang with me on this next slide. So we're gonna have a table for each one of these things. So not, and, or, I wanna show. Starting off with not, I want you to focus on the left side of the table. So A at the top left is kind of just this placeholder. Think of it back to your algebra class. I hope you guys somewhat are okay with thinking of math terms, but think of A as X or whatever, whatever variable we're thinking of, right? And A can be one of 2 values, and that's the left side. So A can be false or A can be true. And then directly on the right side is what happens to A when you apply the Boolean operator, in this case, not. So when I do exclamation point in front of A, that in programming terms stands for not. And so if I say not false, that first row, on the right-hand side, not false becomes true. If I say not true, that second row, not true becomes false. So again, all it's doing is opposite. So if the light switch is off, it goes to on. If it's on, it goes to off. Similarly with and, this is where it gets a little bit more tricky. We introduce two things, because again, this is when we have two separate things that we're evaluating together. Is the username valid and is the password valid? So in this case, think of A as the username and B as the password. And think of the result, false or true, as them matching. So in that, and there's two possibilities for A. It can be true or false. And then there's two possibilities for B. It can be true or false, right? And so if you combine those two together, that means that there can be four possibilities. And so that's why there are 4 rows in this table. So the first row is false and false. They're both false. So neither matched. If neither match, username, password, do not match, then anding them together also doesn't match. They're false. Similarly, if only one of them match, in the second case, B is true, but A is false, that means only the password matched, then it's still false because again, they both have to match. Similarly, in the third row, only the username is true, password is false, it's still false. Only when you get to that last row, that 4th row, when both are true, that's when you resolve to true. So and requires both to be true in order to resolve to true. And you'll see with or, it's kind of not the opposite, but it's a little bit more forgiving, right? So only in the case when they're both false is it false. So, you know, if you're a guest, or if you're not a guest, or you have not exceeded the free limit, then I'm not going to show you the pop-up. And I know that's a lot of nots, but think about it. I've been to your website and I've visited the page twice. So neither of those conditions are true. Neither A and B are true. Therefore, the result of that is false, and I will not see the pop-up unless it's true. I will see the pop-up if either of those conditions are true. So if I am a guest, this is the first time I visited, or I'm past the exceeded limit of maybe 3 articles. So those two cases become true, and then just like with and, if both are true, then it's also going to be true. Okay. Now we move on to a different definition, a Boolean expression. So an expression is a statement which evaluates to a single Boolean value. And we've been doing this already. I've already been talking about this. Logic is essentially making a decision based on the result of an expression. So in the example where I'm logging into my email, the expression is my username matching and my password matching? That resolves to true or false. The decision I make based on that, that's logic. That's more the logic side. So they're pretty coupled together. Today we're going to do quite a few Boolean expressions. Here's an example that I want to start with. And again, this is very formal languagey. We're going to get into concrete examples later, but I kind of just want to really hammer this home and try to make it almost so that you're kind of bored with A and B. And then we'll get into some real examples. So I'm going to give you an expression here. Given A is true and B is false, I want you to evaluate this expression. Parentheses sort of denote that you want to evaluate, just like in math, right? You want to evaluate that everything in the parentheses first. It takes precedence. And so in this case, I have A and B in parentheses, or A and not B in parentheses. And when we're doing programming, we go in order of precedence. So we would be looking essentially left to right, but also within the parentheses first. The first thing that would actually evaluate is not B. So if I go with, or sorry, let's go ahead and plug in the values first. Excuse me. So A is true and B is false. So plugging in the values, this is what we get: true and false, or true and not false. The first thing that we want to evaluate is not false, because that's sort of the innermost thing in the parentheses that has an operator attached directly to it. So not false, if you look at the table above, what do you think that evaluates to? It evaluates to true. So we'll go ahead and show that. I'm bolding the things that have changed. Hopefully that helps your eyes visualize it. So now we have true and false, or true and true. So we've sort of simplified it a little bit, and we're going to keep simplifying it until we get to exactly one result. So now we'll look at true and false, because that's the left-hand side. So true and false would evaluate to, if you look at the third row of our and table over there, true and false evaluates to false. So we've solved that side. Now let's solve the right side. If we look at the right side, we have true and true. That's the fourth row of the and table. True and true goes to true. So we'll go to true on the right side. Oh, and I gave it away. So now we have false or true. And that's the second row of this or table here. False or true, one of them is true, and therefore it evaluates to true. And so coming up from this expression, where this is sort of our functionality, this is our expression, and then our inputs where A is true and B is false. What is the result? Well, we just step by step went through and evaluated the result to be true. Okay, I want to cover one more bit of information that you guys will need to understand to get into the exercises. These ones are a little bit less, or probably a little bit more familiar, I should say, towards the bottom at least. The ones at the top may be a little bit different. So now we're going to talk about comparison operators. And so before we were doing more logical operators, here we're going to compare things. We want to compare if things are equal to each other, if they're not equal to each other, if one is greater than another, less than another, greater than or equal to, less than or equal to, those sorts of things. Those come up all the time, right? We're often comparing, numbers. We're often comparing is 5 greater than 8 or so. So given that x equals 5, I want to walk through a couple examples. Let's start with the operator equal to. And equal to is a double equals sign, and I know that feels a little bit weird, but in computer programming, a single equal sign stands for an assignment, meaning that if I said x equals 5, I would actually be setting x equal to 5. In this case, I don't want to set x equal to 5, I want to compare the value of x equal to some other value. So in this case, if I assume x is 5, I'm actually comparing is 5 equal to 8. Again, if there was only one equal sign, I would actually be setting x equal to 8, which is not what I want to do. So that's why we do a double equals. I know it feels a little bit strange. So with that said, assuming x is 5 equal to 8 is the question. And the answer is no, which is false. Simple enough. The next one is x equal to 5? And yes, the answer is yes, which is true. The opposite of that uses the not operator in front of the equal sign. So exclamation point or bang equals stands for not equal to. And so let's just do the same problems in reverse. X is not equal to 8, so is 5 not equal to 8? Yeah, it's not equal to 8, so that would be true. Is x not equal to 5? Is 5 not equal to 5? No, that would be false. So actually it's going to be the reverse of the above. And then lastly, these are the ones that you are probably familiar with from math. Is something greater than, is it less than, greater than, or equal to? So I'm going to jump through these rather quickly. Is x greater than 8? So is 5 greater than 8? No. Is 5 less than 8? Yes. Is 5 greater than or equal to 8? No. And is it less than or equal to 8? Yes. So we'll get those answers as well. False, true, false, true. Okay, so we've gone through all of the sort of prep. We've done a bit of learning here. I want to take a pause for a second and just see if there are any questions I can answer before we dive into some exercises. Let's see here. If I can find the chat, my mouse is playing with me. No. There we go. Okay, no questions, just Katie messaging. Okay, I just want to double check that just in case. If you guys do have any questions, feel free to throw them in the chat. Again, I'm here to help. Okay, so let's dive back in. And we'll jump into some, so I go through these animations again. We'll jump into some problems. What I want to do is I want to go through a series of problems, and we'll just walk through them one by one, and they're going to increase in difficulty as we go. They're all going to build upon each other, and hopefully they all sort of make sense from just like a universal understanding of, can I drive or not? You know, there's laws in the world of, you know, whether or not you can drive. They do vary state by state in the United States. So I tried to spell out exactly what my interpretation is, at least. So I'll try to make that as clear as possible before we actually answer any of these questions. But let's start with the simplest one. We're going to be writing a function here, and a function or method in code is something that can perform an operation and sort of encapsulate the result. So in this case, we're taking in 2 inputs and we're returning 1 output. You don't have to worry about the syntax. I don't fully want to get into that. But if you can just sort of wrap your head around that, there's going to be 2 inputs, one being whether or not the person has a driver's permit. And then the second is whether or not they are driving with another licensed passenger. And we want to return 1 output, which is the result of a Boolean expression, true or false. Essentially what we want to do is we want to return true if we can drive. And the rules for if we can drive are A, we have a permit, and B, we are with a licensed passenger. So I believe in Pennsylvania, you have to have a driver's permit, and you can drive, while you have your permit, you can drive with a licensed passenger. And so does anybody want to take a stab at the Boolean expression for this one? If not, that's okay, but I just want to leave it open for a second, just in case. Okay, so I'll just dive right into it. So again, we want to say it's true if the person has a permit and they're with a licensed passenger. In this case, or in previous cases, we were using A and B, which were pretty arbitrary. In this case, our Boolean values have names. They have names. And so we actually think of A as has permit, and B is with licensed passenger. So the answer to this one is that the person has permit and they're with a licensed passenger. Don't worry so much about return or this semicolon at the end there. I'm not so much gonna dive into syntax. Let's just focus on the Boolean expression side of things that we learned earlier. So this results in true if I have a permit and I'm with a licensed passenger. If both of these are not true, or one of them is not true, then I can't drive. I'm not allowed to drive. I'm not allowed to drive if I don't have a permit, and I'm not allowed to drive if I'm not with a licensed passenger. So that's you know, the simplest one with just 2 rules. So I want to add some complexity to it. Let's do that. So now we have 3 inputs. We have 3 inputs. So we still have the 2 previous inputs. We have has permit and with licensed passenger, but now I'm also including somebody's age, the passenger's age. Our licensed passenger must be 21 or over. That's one of the rules. So if they are licensed, but they're also 16, then I still can't drive. So a little bit more complex. Don't worry about so much about the, again, the words here, but just for clarification, I didn't spell it out before, but bool holds a Boolean value, true or false, whereas int holds a number. It holds a whole number to be specific. So in this case, a person's age isn't really, I mean, I guess one could argue that it could be 12 and a half or 16 and a half, but we're really going to go with whole numbers here. So we want to see, using those comparison operators that we learned about, if the passenger age is greater than or equal to 21. So in this case, our expression is going to have three things in it, and it's going to get a little bit more complex. I want to say I have a permit, and I'm with a licensed passenger, and that licensed passenger is 21 or older. So let's see what that looks like. So before we just had has permit and with licensed passenger. Now we've introduced this third condition. But again, all of those conditions have to be true. And so we merged it together with and. We merged it with and. Each of them have to be true. If any of those are not true, then I'm not allowed to drive, and thus I would return false. Okay, let's add even more complexity to it. We've got a fourth parameter. So now we need to have a permit, be with a licensed passenger. That passenger's age has to be over 21 unless they are our guardian, in which case they may be 18 or older. So we've introduced a fourth input that tells us whether or not, true or false, is that passenger our guardian. If they are our guardian, then their age only has to be 18 or more. If they're not our guardian, then we still have to do what we did before, and they have to be 21 or more. So again, this is getting a little bit more complex. In this case, we want to say has permit, and I'm with a licensed passenger, or, okay, so let's break this down. Has permit, and I'm with a licensed passenger, and that passenger's age is over 21, 21 or over, I should say, not over 21, 21 or over. So if they're 21 or over, then we're okay. Because whether or not they're our parent, if they're over 21, we've satisfied the logic. However, if they're only greater than 18, then they must be our parent and guardian. So they are either 21 or over, or they are our parent or guardian, and they're 18 or over. So we've introduced an or, and we've introduced some parentheses. So let's walk through this a little bit closer. Let's assume that we have a permit. Let's assume we are with a licensed passenger. Those are both true. And now let's assume that the passenger's age is 17. Let's assume that they're 17 and they are our parent or guardian. So we would come down here and we would say, yeah, we have a permit, that's good. And we're with a licensed passenger, that's good. And the passenger's age is greater than or equal to 21. Well, no, 17 is not greater than or equal to 21. Well, or they're our parent or guardian, yes, and their age is greater than or equal to 17. Or sorry, 18. Well, again, 17 is not greater than or equal to 18. So what's in parentheses here would evaluate to false. False or false is false. Anything added with false is false. Therefore, the answer is going to be false. Do you perform the relational operations before the Boolean operations? Oh, good question, Arnab. So you really perform things in the order of precedence. And so while I walked through that sort of top down, left, right, that's not exactly how it would be evaluated. So the true way that it would be evaluated is by innermost parentheses first, and then left, right. So if I'm actually treating myself like the computer, then I would first start here. I would first start here. And it would say, Is the passenger our guardian, true or false? That's actually was true in this case that I'm talking about. And is their age 17 greater than or equal to 18, which is false. And so this would evaluate to true and false, which is false. That would then collapse. And then it would say over here, is 17 greater than or equal to 21? That's false. Then it would be false or false. And that would collapse into false. And then it would evaluate the top to bottom. Has permit with licensed passenger true and false is false. So that's a great question. Let's walk through it with 18 years old. If I'm 18 years old and all these other things are true, so true and true, passenger's age is, let's do it as the computer. So as the computer, if I am the passenger's guardian, this is true, and my age is 18, which is greater than or equal to 18, that's true. So now we have true and true. That evaluates to true. This is false over here still because I'm only 18. 18 is not greater than or equal to 21. However, false or true is true. And therefore, now we have a condition that's true and true and true. Therefore, we can return true. So you can see how the parentheses really narrow in on the scope, and they're a very valuable tool to sort of isolate almost like a sub-expression, a mini expression that you want to do first. Let me talk about one more thing before I jump to the next slide. If my age is 21, then I can effectively ignore everything on the right-hand side. So if for whatever reason my computer was evaluating one expression here and one expression here, and this side evaluates to true, I can totally ignore the right-hand side because anything or true is true. And so the computer is actually smart enough to sort of optimize in that way if you were curious. If for some reason like has permit or with licensed passenger was the expression, if I had a permit and that was true, then as soon as the computer saw that that was true, it would just say, forget everything else, I don't care, it's true. Just return true. Okay, so let's up the complexity one more level here. Now we've got 5 inputs. And this one is complicated, I'm not gonna lie. So now we have a permit. We're with a licensed passenger. We need to have a permit, and we need to be with a licensed passenger. Our licensed passenger must be 21 or over unless they're our guardian, in which case they can be 18 or over. So same rules as before. And now let's layer on one more rule. And I didn't know this rule before I read it earlier this week. We may only drive with a guardian between the hours of 11 p.m. and 5 a.m. So if we're after 11 p.m. and before 5 a.m., sort of the middle of the night, it doesn't matter if the passenger is over 21, we're not allowed to drive with them. We have to be with our guardian. So this is complicated, right? We need to do sort of the same stuff, but now we need to introduce what time of day it is. That 5th input that we're getting here, let's assume that we're on a 24-hour clock. So the value will be 0 to 23, representing the hours of the day. So 0 being midnight, 23 being 11 p.m. 0 to 12 is what you normally think of, and then 13 would be 1 p.m., so on and so forth. So we may only drive with a guardian if the hour of the day, we may only drive with a, the licensed passenger that is not our guardian if the hour of the day is less than 23 and greater than 5. Sorry, I'm even getting confused here. So we have to be between 5 a.m. and 11 p.m. if we're going to drive with somebody who's not our guardian. So we now need to consider the hour of the day in this statement. So how do we do that? Let's walk through this one. So this one is interesting. And I color-coded the parentheses just to hopefully make it clear where they start and where they end. So you'll notice there's a blue one here. That blue one sort of terminates over here. There's a green one here that terminates here, a red one, they sort of match up. And then the black one is the outermost. So hopefully the color coordination will help you a little bit. The first two lines are what we've been seeing since the beginning, right? We need to have a permit, we need to be with a licensed passenger. But now it's getting interesting. Now it's getting interesting. I can only drive with someone who is not my guardian if it's after 5 a.m. and before 11 p.m. So if for whatever reason it's less than 5, so if it's 4 a.m., that's a problem, or it's after 11, so if it's 24, which is not really going to happen, if it's either of these are true, then that's a problem. And then down here we say, is our passenger our guardian, and are they greater than or equal to 18? So that's that same condition we saw in one of the other ones. So now what we're doing is we're going to evaluate, again, innermost parentheses. So let's assume the hour of the day is, let's assume it's 5 a.m. And let's assume that the passenger's age is 22. They're not our guardian. We have a permit, we're with a licensed passenger. So true and true here, but let's evaluate the innermost parentheses first, which is this green set of parentheses. So the hour of the day, it's actually greater than 5. It's greater than 5. So this evaluates to false. Or sorry, it is 5. Less than or equal to, so that is 5. So that evaluates to true. True or anything is going to be true. So inside of here is true. We then throw the not operator in there, and that makes it false. That makes it false. Is the passenger's age over 21? I said it was 22. That becomes true. True and false is false. We then come down here and we evaluate the thing in the red. Is the passenger our guardian? I said that was false. False and anything is going to be false. The passenger age is 22, so that's true, but false and true is going to be false. So then we have false or false. So at 5 a.m., even if they're 22, they're not allowed to drive us. So I guess it needs to be 5:01 if I interpreted it this way. Or it needs to be 6 a.m., whatever we want to call it. So if we were to say it was 6 a.m., then 6 is no longer less than 5. And that becomes now a false statement. And then, or is 6 greater than or equal to 23? That is also a false statement. False or false is false. Flipping that with the not makes it true. Passenger's age is 22, which is true. True and true becomes true. Then we walk down to this or block, and we can ignore it because we've already got a true. We've already got a true. So we don't actually have to worry about testing if they're our guardian, if their age is greater than or equal to 18. It doesn't matter. True or anything will be true. So then we do true and true and true, and that returns true. So if it's 6 a.m. And the passenger's age is 22, and we have the permit, they're licensed, we're good, we can drive. Let's see if we got a question. In this method, would you only be able to take inputs of exact hours, no input of minutes? That's a great question, Arnab. So you can take whatever you wish. There's even the concept of time and dates within software. I wanted to keep it as simple as possible, but that's also can be a little bit confusing. So I don't have minutes in here, but certainly you could have had minutes as well, and minutes could be anything from 0 to 59, right? So if hour was 5, then I would want to check, is minutes greater than 0 perhaps? And you could even get into seconds or something like that. So it could get really interesting. But yeah, that's a great question. So let's try a different way of thinking about this. Let's say it is sort of the middle of the night, right? It's 4 a.m. If I'm with my guardian and they're over 18, then I should be good, right? So let's say they're 18 years old and it's 4 a.m. I have my permit, I'm with them, they're licensed, We're good to go there. We kind of come down into here. The hour of the day less than or equal to 5 is true. True or anything is true. We not that, that becomes false. Anything and false becomes false. So this whole thing in the blue is now false. So now we're relying on this second part. We have to rely on the second part because the first part is false. So is the passenger our guardian? That's true. And are they 18 or over? That's true. So true and true is true. Now we evaluate the whole thing together in the black parentheses. False or true is true. So that's good. If it's 4 a.m., they're over 18 and they're our guardian, we're good to go. So I know this is complicated, but I want you to recognize something that I didn't put in here. I didn't put in the other hours of the day in this second part here. I could have made sure that the opposite was true down here, but I can also make the assumption that if I am down here that the opposite is true because it wasn't true up here. So it doesn't actually matter because, or sorry, I can't make the assumption that the opposite is true. I misspoke there. I can confirm that the opposite doesn't matter. And that's because of the rules. Think about this. We may only drive with a guardian between the hours of 11 p.m. to 5 a.m. That only has a stipulation on the guardian. The guardian can essentially drive with their child, I guess, or whoever you would call it, their dependent. They can drive with them at any time, effectively, right? That's how I read that rule. If you interpret it a different way, we may only drive with the guardian between the hours 11 p.m. and 5 p.m. That means the guardian can drive with them really at any time. And actually the opposite case is where if you're not the guardian, you cannot drive between 11 p.m. and 5 a.m. So while I said the stipulation was on the guardian, I misspoke there. The stipulation is on the person that is not the guardian. And so that is why the expression only has the piece where they're not the guardian. Because if I am the guardian, I can drive with them at any time of the day. So this is where not comes in, and not often gets you a little bit, tripped up. It can get you confused, but you can kind of look at a set of rules or a set of logic, and you can try to think of it, what makes more sense? Does it make more sense if I take it at face value, or does it make sense if I kind of think about the opposite way? And in this case, it actually makes more sense if I think about it the opposite way. I could have written down here that the time is between, any time of day, but that doesn't really matter. It is going to be between 0 and 23. Okay, questions on this one, or any of them I can go back to. This one is definitely complicated, and I understand that this one sort of threw you for a little bit of a loop. That's it for my slides, actually. So that's the last example that I wanted to present. So I do want to sort of just open it up for any questions that you guys have. That could be about what I presented. It could be anything related to software. Yeah, I do ask that if you have questions about Tech Elevator, I'm willing to answer briefly, but I think for the most part, you would direct those towards Katie. How would you have done it without the not statement? Good question. Okay, so without the not statement, let's think of it a different way. If I remove this not, then I can say, rather than when I can't drive as a guardian, let's talk about when I can drive. And so if the hour of the day is greater than 5, and the hour of the day is less than 23. If I and all those together, then I'm valid, I can drive. I kind of did it this way because I wanted to show how to use the not and the or. but also because it kind of reads decently to me as well. But yeah, the way that I could do this without the not statement is I'd remove this not and I would just say, if the passenger's age is greater than 21 and the hour of the day is greater than 5 and the hour of the day is less than 23. So meaning it's kind of between, right? So it's either, 5:01, which I didn't have minutes, or 10:59. Any other questions, guys? Happy to answer anything you have. Are there any other Boolean operators? No, there are not. I paused there because there are other operators that one could get confused with Boolean operators. You'll notice that we have double and symbols and double bar symbols to mean or. There are actually operators that are just singles of those, but those are a whole nother animal and they operate on bits. You know how your computer, you've probably heard, is binary. It operates in zeros and ones. If you want to manipulate zeros and ones as true or false, you can do that with the single version of the and the or. But that has a whole nother lesson behind it. Not something that I would teach over this. That's a good question though. And then there are all kinds of other operators that aren't necessarily falling into the Boolean operator world. There's all kinds of mathematical operators, right? There's plus and minus. There's the assignment operator that I referred to earlier, just the single equal sign. That might be there's a modulus operator. So again, not a Boolean operator, but if you wanted to take the remainder of something, just like in math, you do division, you get the remainder. There's an operator for that as well in software. There's the division and the multiplication operator, which is just the slash and the asterisk. I think that sums up all the operators. So hopefully, I don't see any more questions coming through, but hopefully this has piqued a little bit of an interest. It's really, again, we're just walking back to the beginning. It's really just logic, right? We're just trying to answer a question. Can I drive? At the end of the day, can I drive or not? And that question comes with a number of inputs that are run through a set of rules, and we get an output, yes or no, true or false. So hopefully that's a little bit interesting to you guys. Whether or not, I really thank you for coming. It was great to have you, great to present.